This is part 4 of 4, going through a 40-question IB higher level physics multiple choice paper. If you want to find the unanswered questions, they're in the link in the description. And if you want to find the annotated mark scheme, that's also in the link to the description. If you want to find the other 3, the part 1, 2, and 3, they should either be in this playlist or they should be also in the description link. Okay, question 31. Unpolarized light is shone through 2 identical polarizers whose axes are parallel. What's going to happen? Well, here you've got a polarizer 1, and remember that going through a single polarizer, the intensity coming out is always going to be 50%. So that is going to be 50% of the first one. But now the light is totally polarized. So when it goes through the second polarizer, it doesn't lose any more intensity because this polarizer is aligned in the same direction. So here it's 50% because it's unpolarized light going through a polarizer. But here it's not going to be polarized any differently because the axes are the same here. So this is still going to be 50% coming out here. So the ratio is 50%. 32. The energy E of a photon is given by E equals hf. The SI base units of H can be given as what? Okay, well, to work out the SI base units, we need to just think about the equations first. So we want to find H, so H is E divided by F. Now frequency is an easy one because that's in seconds to the minus 1, or hertz, which is seconds to the minus 1. However, energy is slightly more complicated, so at the moment we've got joule seconds. Now, how do we do joules? Well, there's several different ways that you can convert joules to base SI units. I'm going to choose a common equation for energy, which is gravitational potential energy, mgh. So I've got the mass, kilograms, gravitational acceleration, which is meters per second squared, and height in meters. So the energy here is kilograms, meters squared, seconds to the minus 2. Remember, we've got joule seconds here, and this is just joules. So so H is that. So the units of H is joule seconds. So the unit of H is energy times seconds. So this is energy. So here's seconds. So the units of H is kilograms, meters squared, seconds to the minus 1. A. (33) A bob of mass 0.5 kilograms is suspended from the end of a piece of string 0.45 meters long. The bob is rotated in a vertical circle at a constant rate of 120 revolutions per minute. What's the tension in the string? Okay, well, when the bob is at the bottom, not only does the tension have to balance the weight, but it also has to provide the centripetal force. So the tension is the weight plus the centripetal force. Now, we don't really have all of this stuff, but we can figure out V because we know that V equals omega R. And omega is 2 pi f. So for the frequency would be how many revolutions happen in a second. This is per minute, so we need to divide that by 60. So the frequency is 2 hertz. So the velocity is 2 times pi times 2 times the radius, which is 0.5 meters. So then we have an equation for the tension, which is 0.5 times 9.81 plus 0.5 times 2 pi times 2 times 0.45 divided by R. Oh, that's got to be squared, sorry. Divided by 0.45. Which gives you, if you square all of that lot and then you calculate it, it gives you a tension of about 40 newtons. D. Okay, question 34. Which statements about protons and neutrons is correct? Let's go through them one by one. Well, leptons are electrons and things like that. So protons and neutrons are definitely not leptons. Protons and neutrons contain the same number of up quarks. Well, you should know that protons are up, up, down, and neutrons are up, down, down. So that's definitely not the same number of up quarks. Protons and neutrons have the same baryon number. Well, each one of those quarks is worth a baryon number of a third. So the baryon number of a proton is 1 and the baryon number of a neutron is 1. So the answer is C. Finally, just to make sure that we're right, protons and neutrons have the same charge. Well, you know that protons is plus and neutrons is 0. So it's definitely not D. 35. This one's a force diagram. We know that the rod is in equilibrium. So we know that the vector triangle would be a complete triangle if we drew a vector triangle. Which of the following diagrams best shows the correct direction for the reaction force R at the hinge? Well, if it's going to be a complete triangle, then the reaction force R from here has to balance both this force here and this force here. So it needs an upward component that's equal to the weight. So it needs an upward component of about that much. And it needs a right direction component that's equal to that force. So about that much. If we combine those two, then we end up with a force that looks something like that. So the only one there that looks anything like that is D, R, up and to the right. So the answer is D. Okay, 36, a particle of mass 2m, that's the key thing here, and velocity v strikes a wall. The particle rebounds along the same path after colliding with the wall. The collision is inelastic. What is the possible change in momentum of the ball during the collision? Okay, well, the initial momentum here is mass times velocity, which is 2mv. So if the momentum only changed by mv, then the momentum would still be in the same direction, but it would have been halved. So the ball would continue moving through the wall, but just at half the velocity. So it's definitely not that one. If we look at 2mv, then the initial momentum is 2mv. Then here, that would be the momentum. And if the momentum changed by 2mv, then it would just go down to 0, so the ball would stop, and we know it rebounds along the same path, so it can't be B either. If it was 4mv, then the ball would bounce, and it would bounce off, and the momentum afterwards would be 2mv, but in the opposite direction. If the momentum was 2mv in the opposite direction, then the velocity would be exactly the same when it was going the other way, and so the collision would be elastic, kinetic energy would be conserved, so it can't be D either. So it must be C, so the ball rebounds with a mass of 2m and a velocity of v over 2, which gives you a total momentum of mv afterwards, but in the opposite direction, so the change is 3mv. So the answer is C. Okay, 37. Which graph shows how the kinetic energy and the potential energy and the total energy of the satellite vary with distance x from the center of the planet? Okay, there's two ways to look at this. First of all, you know that the total energy is the kinetic energy plus the potential energy. And if you think about that logically enough, then you will see that the only option for that is B, because potential energy is negative, kinetic energy is positive, so you've got to find E in the middle. E has to be in the middle of the two. However, if you wanted to think about that a different way, you could think that, well, kinetic energy is going to be positive, but potential energy, gravitational potential energy, is always negative, because work done moving something from infinity to a point in a gravitational field is always going to be a negative amount of work. So the potential energy of an object in a gravitational field is always going to be negative. So EP is going to be the most negative. So then you can have either this one or this one, and the kinetic energy is going to be positive because it's equal to half of the potential energy, but half of the negative potential energy. So it can't be C either. So it must be B. Okay, question 38. A wire carries a current of 2 amps for 1 hour. How many electrons pass? Okay, this is reasonably simple, so we just need to figure out the charge, first of all. So current is charge over time. Charge is current times time, which is 2 times 1 times 60 times 60, because we've got to put it in seconds. 6 times 6 is 3,600, so 3,600 times 2 is 7,200 coulombs of charge. How many electrons is that? The charge on one electron is 1.6 times 10 to the minus 19 coulombs, so 7,200 coulombs, 7,200 divided by 1.6 times 10 to the minus 19 gives you an answer of 4.5 times 10 to the 22 electrons. 39, what is the unit of resistance when expressed in SI base units? Okay, this one is very similar to the other units one that we did further up the page. Here we have resistance is voltage divided by current. Voltage is energy divided by charge. Just like we did above, we can use energy as mgh for figuring out the units, which gives us kilogram meters per second squared meters. So then we've got energy. We need to divide that by charge. A charge is current times time. So the units for charge are amp seconds. So then we have, for the units for voltage, we have kilogram meters per second to the minus 2 meters divided by amp seconds. So let's multiply that through. We have kilogram meters squared seconds to the minus 3 amps to the minus 1. And then we put that back into here, and we just need to divide it by amps again. So the units for R must be kilogram meters squared seconds to the minus 3 amps to the minus 2, which gives us B. Finally, question 40. The diagram below shows a current I in a wire placed at an angle phi inside a uniform magnetic field of field strength B. The magnetic force per unit length of the wire is M. The field strength B is given by what? Okay, so we know that F equals B-I-L, and here we've got phi, and if you imagine that the current and the field are at right angles, that would be the greatest amount of force on the electrons, so that would be when phi is 0. So when phi is 0, then the force is at max. The trig that we need to use there must be cos, because when phi is 0, cos phi is at max. And so we know that the magnetic force per unit length of wire is M. So we've called it F, but we're going to change that to M. M equals B-I, and we're talking per unit length. So actually, M is F divided by L. So we can move that L down here. And so then we have B-I cos phi, and we just rearrange that with respect to because we're trying to find the magnetic field strength B. So B equals M divided by I cos phi, which is option B. That was part 4 of 4. If you want to download the annotated mark scheme, feel free to do so from the links below. Thank you very much.